Hi guys, it's nice to see you again. Um, Today in class, I gave my students some questions, and one of the questions is on the board. Uh, the question on the board is quite easy, but you don't have to dive into it. You have to observe it very well, because if you attack this question, you may likely pick the wrong answer. The question states, which law states that the pressure of a fixed mass of gas is directly proportional to its density? Nice question. Now, majority of my students picked pressure law like normal. Pressure is in the question, so it should be pressure law. Others went with Graham's law. I understand why. Because in Graham's law, we could see density. Graham's law of diffusion and effusion, which states that the rate of diffusion or effusion of a gas is inversely proportional to the square root of its vapor density. Understand? However, the answer is not option B, pressure law. The answer is not option C, Graham's law. The answer is not option D, Charles' law. The answer is Boyle's law. You're surprised? Yeah, I know you know the regular Boyle's law statement. Of a the volume of a fixed mass of gas is inversely proportional to its pressure, provided temperature remains constant. Yes, from that concept, we can also restate Boyle's law as what we have on the board. I'll show you, I'll prove it to you, and you will agree with me. Now, but before I do that, please uh, share this, like it, comment, allow others to learn as you learn. Recall that I am IY Elvis, popularly called Ever Noik. So let's see why it is Boyle's law. Now, let's go there. Now, we have to work with the normal regular statement for Boyle's, which say that the pressure of a fixed mass of gas is inversely proportional to its volume. Same thing. The volume of a fixed mole of gas is inversely proportional to its pressure, provided temperature remains constant. So what you're trying to say here, that if temperature and amount of the mole is constant, the volume is inversely proportional to pressure. Pressure is inversely proportional to volume, vice versa. So let's use that. Pressure is inversely proportional to volume. This is Boyle's law. Now, we can actually solve with this sign of proportionality. We equate it and introduce a constant. Now, P is equal to K over V. Same thing. Now, what is density? The density of a gas is equal to the mass of the gas over the volume of the gas. Now, there's a relationship between density and volume. What's the relationship between density and volume? Volume is equal to mass over density. So I can work with this, right? Now, I can equate the volume in Boyle's law to mass over density. Anywhere I see volume, I can put mass over density. So, P, that is equal to K over V, now will now be equal to K over, what is V? V is equal to mass over density. Mass over density. Now, K over M over D is same as K divided by M over D. Right? Yes. K divided by M over D mathematically is equal to K times D over M. Right? Yes. So in this case, can I say that P, that is equal to K over V, is now equal to K times D over M? Right? Yes. From this question, the mass is constant and our K is constant. We can actually remove it by default. So my P is equal to m, or add the k is equal to d, and add the k to it. Any constants associated with it will follow this my d. So from this, I've been able to prove to you that from Boyle's law, same Boyle's law that states that volume is inversely proportional, pressure is inversely proportional to volume, is the same Boyle's law that is also stating that the pressure of a gas is directly proportional to density. Now, this is applicable to pressure. Pressure in height decreases, while pressure with depth increases. That is why if you move up the mountain, the pressure of gas in a high mountain is low. Why? Because the density of gas there is low. At high altitude, air is less dense. Because air is less dense, the pressure of air there is very low. So you see now that that law from Boyles, which states that the volume or the pressure of a gas is inversely proportional to its volume at a constant temperature, it is also the same statement that states that the pressure of a gas is directly proportional to its density. So my answer is not pressure law. No. My answer is not Graham's law. No. My answer is not Charles's law. My answer is Boyle's law. So I hope you find this interesting and educative. So I'll call it a big pause here until we see again.